Yeah, we still have two more EDTA techniques. One is displacement titration. For example, in the mercury ion does not have a satisfactory indicator. So the idea is that mercury ion is titrated with excess magnesium EDTA complex. Okay, and then since the mercury EDTA complex formation constant is much greater than magnesium EDTA complex, so now mercury displaces the magnesium ions, and then the displaced magnesium ion is titrated with standard EDTA in a solution. Okay, so the condition, you know, necessary condition for this technique is that formation constant, conditional formation constant for mercury EDTA should be larger than magnesium EDTA complex, right? And this is equation. This one is displaced, okay, this magnesium ion, and then liberated magnesium ion concentration is the same as this unknown metal ion concentration. Okay, and another example is that no suitable indicator for silver ion, but silver ion can be displaced nickel from its complex. In this case, okay, although this one doesn't have a EDTA, but that doesn't matter. Silver ion now displace this nickel, okay, and then liberated EDTA, the nickel ion can be titrated with the standard EDTA concentration. It's a solution. But here now, you must exercise the carefulness, because two silver ions now displace only one nickel ion, right? So you have to be careful with this stoichiometry. And final technique is indirect titration. Okay, indirect. The usually metal ions, which are all the cations, but anions can be analyzed with EDTA. For example, this carbonate ion, chromate, sulfite, and sulfate. How? How does this titration proceed? For example, let's assume you want to determine sulfate ion, yeah, in solution, and first you add this barium ion and then barium sulfate. Yeah? This is not very soluble. It precipitates, yeah? And then you filter out this solid and wash it carefully, and then this one you add in water and boil. You boil in the presence of excess EDTA. Boiling makes the process rapid. Okay, and at constant pH 10. Yeah. Now this one, in the presence of excess EDTA, barium ions are liberated from this barium sulfate and makes complex with EDTA. And then excess EDTA is back titrated with magnesium ion. In this case also, the Kf for magnesium EDTA must be smaller than barium EDTA complex formation constant. Okay, yeah, that's the only condition. And there is a concept of masking. Masking is protecting some component of analyte from reaction with EDTA. Okay, let's assume you have a mixture of aluminum and magnesium ion, and first react with fluoride ion and then aluminum fluoride, hexafluoride. Yeah? So in this way, you know, uh, aluminum, free aluminum is removed from the solution, and then remaining magnesium ion can be titrated with EDTA. Okay, so in this case, fluoride ion is a masking agent. Okay? Likewise, cyanide ion, mascus, cadmium ion, zinc ion, like mercury, cobalt, copper, like that. Not magnesium, calcium, manganese, and lead ions. This one, fluoride ion, mascus, aluminum, ferric ion, titanium, tetravalent ion, beryllium ion. Okay, and three, ethanolamine, mascus, aluminum, ferric, and manganese ions. And three, dimercapto 1 propanol, mascus, bismuth, cadmium, mercury, and lead. Okay, yeah, they are masking agents, but there are also demasking agents, okay, which is release metal ions from masking agent. For example, cyanide complexes can be demasked by formaldehyde. Okay, here metal and cyanide ion make a very stable complex, but in the presence of formaldehyde in acidic condition, this one metal ions are liberated. Yeah, so here formaldehyde is called demasking agent. Okay, yeah, yeah. This is the end of chapter 11, and here is the homework problems, and you solve these problems and upload. And by the way, some students ask me that the solution, problem solution, but in the internet you can find um, the solutions, and I linked that website, and you visit that website, and then you can download whole problems set, okay, problems solution set, okay, solutions, right? But I cannot um, upload that solution on the eCampus because that is against the law, okay. But I hope that you to find the solution from the internet, okay.